And so some background information to the calculation. So this is presenting calculations as I'd like to present them and review them. So light timber frames, as designed by NZS 3604, usually have an assumed ductility of 3.5 due to the jib board bracing. Now, this is quite a novelty to me because coming from England, we don't consider plasterboard to be a structural material, and we certainly wouldn't consider plasterboard to be ductile. However, jib has done a very good job at persuading the New Zealand industry that jib is not only a fine structural material, and it can perform in a ductile manner under seismic loading, and they've done some tests to prove that. It does feel counterintuitive, especially as the second part of it says that the steel frame is not ductile, i.e. you're using a ductility of 1. Well, this confused me no end. How does plasterboard get a ductility of 3.5 when steel only gets a ductility of 1? Now, we all know that steel is a highly ductile material, and you would normally have a ductility mu factor bigger than 1. However, in the case of a timber-framed house, which is really what NZS 3604 is aimed at, the portal frame, the steel portal frame, is not likely to go beyond its elastic limit. It's not going to go plastic, so you're not going to get ductility. You're not going to be looking towards ductility. On the other hand, how does plasterboard get a 3.5 ductility? Well, it's because of your nailing or screwing your plasterboard onto a timber frame. And the ductility comes from those fixings under a seismic load, or any dynamic load for that matter. When you push this timber frame wall clad in jib board, it will deform. And as it deforms, the metal of the fixings will start to go ductile. That's where the ductility comes from. So the design philosophy is based on the following assumptions. You have an ultimate deflection of your frame, and it's limited to 1% of the story height. So height over 100 for wind and seismic at ultimate limit state. You then limit the serviceability limit state deflections to height over 300. And there we have our mu factors of 3.5 and 1 for jib board and the portal frame respectively. So MathCAD allows you to define units, and so jib has defined the unit of a BU. What on earth is a BU? It's a bracing unit. Well, it's simply 1/20th of a kilonewton. Why didn't they just use newtons?